And now we are going to get into my mod code. I'm using Harmony for my mod. So Harmony is available as an extra mod on Nexus. So in modules we can see I have my Harmony mod here installed, and I'm going to reference this Harmony mod here in my mod. For that we can go to our right in our Solution Explorer. We have here our mod name project. We can open that. Then we have here references. We can open that and see, okay, I'm currently using systems. I'm using system core, data XML. Those are just your basic Microsoft code references. They are basically used every time you code anything. Then I have already added Tailworld's core, Tailworld's engine, Tailworld's library, and Tailworld's mountain blade. Tailworld's mountain blade is required here for our MV submodule base. And now I'm going to right click on references, add reference. I'm going to browse. And now I'm going into my Bannerlord modules, Bannerlord Harmony, bin, shipping client, and here oharmony.dll, so the bigger files of those two, and click on add. And OK. Now we can see on references the oharmony reference has been added. And with that I can now go into how to use Harmony. Harmony is used to patch code in real time. So Bannerlord is a finished product. It has thousands of code lines inside, and they're going to be run. And what Harmony now does is Harmony can search for a specific line in this code. I'll show an example in a moment. And you can, with Harmony, replace these lines of code with your own. And this process of searching and replacing code in Bannerlord is called patching. So what I did is I got into my on submodule load. So before we're in our main menu, and I'm adding basically I'm saying, okay, I want a Harmony I want a Harmony object. My code doesn't know what Harmony is at the moment, so this is underlined with red. You can click on that, and then you will get a light bolt, and he says I'm using Harmony lib, so I'm adding this library to my references in this class. So I say I use Harmony, then I'm creating a variable Harmony equals equals a new Harmony object, and this is just the name, so you can call this whatever you want. It should be it should be this the most descriptive you can be. So the best name would probably just be your mod name to use. So this is what I did. I called this my mod name and added patches. Now we use this Harmony object. We Harmony dot, and now we can patch all, call the patch all method. What this does is Harmony is going to take all our patching code we will add in this mod and apply them to Bannerlord. This will execute every patch we add. With this, the main mod is pretty much done, main class. Now, what I've done, I've added a new folder called it patches, and in this new folder I added a new class with the template class. You can name it whatever you want. I've called it shield hit patch here. And this is now my harmony patching class. So we have here our class, and now we are going to annotate this with a harmony patch. With this annotation, here our harmony patch all knows, okay, this is a class I'm going to read and execute. Then now we're getting into our actual code patching here. So in this class I'm executing 3 different patches. So this here is one patch, this here is one patch, and this here is one patch. All of those 3 are independent of each other. They are just in the same file. Now, Harmony has a very strict setup. So, let's have a look. I'm adding a new method. I'm setting this as private. I'm pretty sure this could be public as well, so doesn't really matter here. Then I'm saying it's static. This has to be static from Harmony. This is a requirement. And I'm saying it will be returning a Boolean value. But that's the first possible setting. You can also use void. Void says there will be no return value. This return value has a special meaning in Harmony. If you want, you can have a look at the Harmony documentation on how this exactly works. I can give a brief explanation. Next, the next one is here the name of this method, so you can call this however you want. I'm calling this one the same as the method I'm going to replace and add the word patch at the end, just so it's more descriptive for me, so I know what this one actually does. Okay, let's ignore those parameters for now, and let's have a look at my 2 annotations I added on top of this method declaration. The first one is a Harmony prefix. This tells Harmony when to execute this patch. So there are 2 possible settings. So we have a Harmony prefix. With a prefix patch will be executed before the original method is going to be executed. And then there is the Harmony postfix. Postfix means this method will be executed after the original method in Bannerlord has been executed. So for my use, I'm going to say this is a prefix. Then the next annotation is a Harmony patch. So I'm telling this method is the patch. Then I'm saying this patch is the type of, and here I say which class in Bannerlord. So mission is a class in Bannerlord. If you want to have a look, we can press Ctrl and click on this mission. Now we can have a look at this Bannerlord class. As you can see here, it's in Tailwords, Mountain Blade. This is a public sealed class mission, and this class has all this code inside of it. So that's almost 500 lines of code. And just for context, missions, the mission class is responsible for combat in battles. So you can already see we have here variables max runtime mission object, so we can have a max of 4k objects in a scene, we can have a max damage of 2k, we have nav mesh IDs, we have modified damage, and we can disable dying, so here we have is in photo mode, for example. Here we have our teams, so team collection teams. I'm pretty sure this will be the attacker and defender sides. We have the player team, we have a attacker and a defender. We have a scene name in this class. We have so we have all kinds of interesting code inside of this. And we can go back into my code. So we are going to we're going to tell Harmony we want to replace some kind of code in this class. Okay. Now we go back and we have a look at this one. We have a string of register blow. This here is the method in mission we want to replace. So we can copy this and go into the nspy, into this mission class, and we can search for register blow. And here in line 4600 something, we have a private void method called register blow. This register blow is taking in the parameters of type agent, game entity, blow, attack collision data, mission weapon, and a reference to combat logic data. We will keep this in mind. So we have all this data. And then we can have a look at the source code. So we have all this logic on when a weapon is going to actually do damage and when it's going to be deflected by a shield, for example. So very interesting code right here. Now we can go back into my code and we can have a look at our parameters. The first parameter is of type mission, called underscore instance. This one is special and this one will be used by Harmony. Then we have type agent, game entity, blow, attack collision data, mission weapon, combat logic data. So as we have seen, all these parameters are the same as the original source code parameters. So you can just go and do a copy paste of these as the input parameters. What is this mission underscore instance? This name has to be underscore instance. This variable is of this type we are patching up here. So with this variable we can get a object of the type mission class. Why do we want a object of type mission in this code? We can have a look why I do need this. I want to access mission behaviors. This is a variable in the mission class. So we have here a public list mission behaviors. This is just a variable, and for that we want to have this instance. So with underscore instance, dot, now we have access to every variable and every method there is in this mission class. This instance variable is very, very powerful. So I could, for example, say here all agents. So these are all soldiers from defenders and attackers. All agents, let's say this is a list, so I could say all agents parentheses at point 0. So this is the first agent dot, and now I have all the data of this agent. I can, for example, go in and say we have a method die. So this die does need a blow, so I could add a new blow. And then we want a agent kill info, so kill info, let's say it was a headshot. As you can see, I can, with this instance variable I'm getting here from the class I'm patching, I can do a lot of things. Well, basically, I have access to the entire Bannerlord source code with this one. Very, very powerful. Let's get back to my actual code, what I'm doing here. So just a prefix, so this method will be called before this method will be called. This is important to keep in mind. Okay, what I'm doing, I'm checking if victim body is the collision data victim body part. Okay. Then I'm checking if the collision data is tells me if the attack was blocked by a shield or the attack collided with a shield on back. And then I'm saying okay, I'm registering a blow, so something was hit. And then I'm returning false or true. Why is this important? Returning false in a prefix of type bool. This combination is important. It has to be a prefix of type bool. When I return false, this means the original method will not be executed. So if this if is true in my code and I return this false, in the mission class, this original register blow method will no longer be executed. This will be completely skipped. If I return true, then the original method will be executed after my method. This is important. With this code, you can replace entire code parts of the original code. You can not only modify code, you can cut out code. This is also a very, very powerful. Let's continue here. There's my second patch. It's also a prefix. It's also patching something in mission. It's the method is called decide agent hit particles. So here private void decide agent hit particles. We have here our parameters, and so this method decides if as the name suggests, if particles will be spawned on a hit. I'm patching this method, so it's also a static bool of prefix, and we have again here return true and false. This time I'm not having this mission instance, so you don't have to add this one to your parameters. You can ignore it if you don't need it. So I'm just having the parameters the original method has here. And then I'm checking if the collision was with a shield on back. Then we don't spawn any particles and we return false. So here the original method will not be executed. If it wasn't a collision with a shield on the back, we return false. So we just execute here the original method. Very easy, very simple code here. And now to the final patch I'm doing. This is interesting. It's a postfix. It's also patching something in missions. This time the missile hit callback. So this is a pretty big function. It's it's very big. So here, this is all the function I'm patching. As usual, we have here our parameters. That's interesting. First of all, this is a void method, so I'm not going to do any returns. well, okay, this is already a postfix, so we can't skip the original method. This method is already being executed after the original method was executed. Then we have here all our parameters, just the same as here in the original. And then I'm executing my code. Here, no particles, basically. So if it was a collision with the shield, we don't have any particles. Very easy, very simple. Yeah, that's already it.